This is lesson IA10 and we are continuing to factor polynomials. This time we're going to focus on factoring binomials. Two-termed polynomials. Once again, I'm going to review some multiplication. If you have a sum and difference product, for instance, x plus 2 times x minus 2, the product of the first was x squared. We found that the outer and the inner products canceled, so we didn't have to spend time on them. The product of the last is minus 4. The result that you always get is the difference. Please notice that it is the difference of a perfect square and another perfect square. So you may want to review your perfect squares as you enter this lesson. We are going to look at binomials of this format and we're going to factor them into both the sum and the difference of the square root of the first term and the square root of the second term. All right, so let's take a look at what we've got. Problem number 1. It actually says factor the difference of two squares. Even if it didn't say it and you looked at it, you would think the following things. First, is there a GCF? Never forget to look for a GCF. The second thing you do is count the number of terms. If there were 4, you would have done grouping. If there were 3, you would try trial and error, but there are 2. So the next question you ask yourself is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Is the sign between them minus? It must be minus. The answer is yes. So the factors of this are really quite easy. Two binomial factors, one with a plus, one with a minus. The square root of x squared is x. The square root of 16 is 4. And we have our factors. Let's look at number 2. Is there a GCF? No. How many terms? 2. Is the first term a perfect square? 4x squared? Yes. Is the second term a perfect square? Yes. 25. Is it minus? Yes. Then the factors, and I'm going to write them down here this time. 1 plus, 1 minus. It doesn't have to be the plus first. It's just what I'm used to doing. So I will get 2x in the first spots because that's the square root of 4x squared. And then it will be plus 5 and minus 5. Next one. 121x squared minus 196y squared. That means no common factor, 2 terms, 121x squared, is it a perfect square? Yes, that is 11 squared. 196 squared, is that a perfect square? Yes, it's 14 squared. Remember that you could certainly just go in here and do second square root 196, enter, and there's our 14. So we don't have to memorize them, but it really will save you some time if you do recognize many of them. It is the difference of squares. There is a minus sign. So 1 plus, 1 minus. It's going to be 11x in the first spots and 14y in the second. Don't forget the variables x and y. All right, number 4 is going to let us work a little bit harder. No GCF. It is a binomial. Y to the 4th is a perfect square because its exponent is even. 81 is a perfect square. Its square root is 9 and it is minus. So the first thing I will do is factor into two binomials. 1 plus, 1 minus. It's going to be y squared because the square root of y to the 4th is y squared plus 9, and minus 9. In our previous problem, we were finished, but in this problem, we're not. Here's the reason. The first factor is finished, y squared plus 9. Those are squares, but that's a plus, and we can't factor it if it's a plus. But this one, these are still squares, but it's still a minus. So this can factor again. 1 plus, 1 minus. The square root of y squared is y. The square root of 9 is 3. So my answer that I type into my math lab must have all of this. Once in a while, a problem exists where when you take the square roots, you end up with still square roots, and the one with the minus can be factored further. Let's look at that again with number 5. No common factor, binomial, perfect square, yes. Perfect square, yes. Minus sign, okay, we can factor. 1 plus, 1 minus. The square root of 16x squared is 16x to the 4th is 4x squared. The square root of 81 is 9. I always look at what I've got to see if maybe I can go any further, because I have a perfect square and a perfect square, but oh, I have a plus. This factor is finished. I have a perfect square and a perfect square and a minus. I can go further. So let me copy down the first one, 4x squared plus 9. Let me factor the second one further, plus and a minus. The square root of 4x squared is 2x. The square root of 9 is 3. You must write all of this or type all of this in order to have it factored completely. Our next problems, I'm going to go ahead and do the multiplication, but you may not remember, encountering a problem like this. All right, so I like to review some multiplication. Sometimes, and you can't really, you probably have not had enough examples to predict this, but sometimes something unusual happens when you multiply certain binomials and trinomials that have a relationship. If I use the distributive property and multiply, x times x squared is x cubed. X times 3x is 3x squared. X times 9 is 9x. Now I'm going to distribute the minus 3. Negative 3 times x squared is negative 3x squared. I just decided to line it up here under its like term. Negative 3 times positive 3x is negative 9x. Negative 3 times positive 9 is negative 27. Because of the relationship here, those terms cancel out. You're left with x cubed and minus 27. This is called the difference of cubes. So you just might want to try to remember some of the cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216, and so on. You can check a number to see if it is a perfect cube. The number 1000. Suppose you wanted to know, is 1000 a perfect cube? And if it is, what is its cube root? You can do the math key. Choice number 4 is cube root. Say you put in 1000. Enter. 10. So 10 cubed is 1,000, meaning that the cube root of 1,000 is 10. I believe in your packet, page 14 has a list of these powers, so that could be useful. When we work with cubes, the difference of cubes and the sum of cubes are both factorable. Under certain circumstances with different signs, this could have resulted in the sum of cubes. Both are factorable. And we're just going to go ahead and jump in. Let's take a look at our problem number 6. First, you have to be able to identify it as either the sum or difference of cubes. Now remember, when it's squares, it must be only difference. But with cubes, it can be a plus or a minus. So I think, even though this is the problem, I'm going to also, just for comparison, show you this. All right, when you have no GCF, it's a binomial. The first term and the second term are cubes. It doesn't matter whether it's a plus or a minus, they can both be factored. Let me work with this one first. All right, if you determine it to be the sum or difference of cubes, it factors into a binomial times a trinomial. So you will do a small set of parentheses and then a large one. In the first one, you get the cube roots and you keep the sign. The cube root of x cubed is x. Keep the sign. The cube root of 8 is 2. It is going to be these two terms that help you build what goes in the trinomial. The first position is square the first. So it's going to be x squared. Then you're going to change the sign. So if this is plus, this is minus. If this is minus, this is plus. For the second term, it's going to be the product of these. X times 2, we'll call it 2x. The last term is another square, which means it's going to be positive, plus 4. Now if I take all of the writing away from that, I got x plus 2, open parentheses, x squared minus 2x plus 4. Let's come over here and see how it differs if we do it with a minus. It is the difference of cubes, so I will put down small parentheses and larger. In the first one, cube roots. The cube root of x cubed is x. Keep the sign. The cube root of 8 is 2. Now we will use these. Square the first one, x squared. Change the sign, so I put plus. Product 2x. Square the last one, always plus 4. So I literally remember for myself that in the binomial I get the roots. But then I get square, change sign, product, square. And I actually say that to myself. Square, change the sign, product, square. So I recommend you do the same. All right, let's look. We will not do 2 problems for each one of these. I see it is no GCF. I see a z cubed, so I think it might be cubes, but I've got 512. I'm not sure. So I go here, I do math. Choice number 4, I put in 512, enter, 8. So it is a perfect cube. All right, I will do a binomial and a trinomial. in the first one, roots. Z is the cube root of z to the third. Keep that sign. The cube root here was 8. What goes in here? Remember the words. Square, change the sign, product, square. Square. Square the z for z squared. Change the sign. Make it plus. Product, 8z. Square the last one, and it's always plus, 64. So if you can remember that little saying that I say, square, change the sign, product, square, you will get these quite easily. And I say the same thing whether it is the sum or the difference of cubes. Let's look at number 8. No GCF, binomial. The cube immediately makes me think about cubes. 8x cubed is a perfect cube. 27 is a perfect cube. So I will try parentheses and then bigger. First one, the roots with the same sign. The cube root of 8x to the cube to the third is 2x. Keep the minus sign. The cube root of 27 is 3. What do I do here? Square. 2x times 2x is 4x squared. Change the sign, plus. Product, 6x. Square the last, plus 9. If you can remember, square, change the sign, product, square, you'll get it. Number 9. This is the sum of two cubes. The cube root of 125 is 5. So the cube root of that entire term is 5x. Keep the plus sign. The cube root of 64 is 4. Now be careful. 64 is one of those unusual numbers. It is a perfect square, but it is also a perfect cube. Now square 5x times 5x is 25x squared. Change the sign. Product, 20x. Square the last one, plus 16. Let's try one more. If you saw this and you were asked a factor, is it the different? You would say there is no common factor. It is a binomial. It's not squares, it's cubes. Small parentheses, large. Cube root of 8x cubed is 2x. Keep the minus sign. The cube root of 125 is 5. Square the first one, 4x squared. Change the sign, plus. Product, 10x. Square the last, plus 25. Now that was kind of a short lesson, and we had difference only of squares, but the sum or the difference of cubes. By the way, I didn't say it, but if you have x squared plus 4, which is the sum of squares, that is prime. Okay, so we can never factor those in the real numbers. All right, good luck. Do the short homework assignment.